Today I'm going to tell you about my research on coherent control, which basically means I use lasers to make things do stuff. But first, let's talk about your smartphones and your computers. Current flash memory operates on microsecond timescales. But what if I told you there was a way to make computers 1,000,000 times faster? Computers operate using binary, and that means the fastest a computer can do something depends on the speed it can switch a 0 to a 1. And those zeros and ones have to correspond to something physical. So that's where lithium niobate comes in. Lithium niobate is a ferroelectric crystal, which means that its atoms are positioned so that the charges add up to point a specific direction. And if I can move those atoms just a little bit, the charges add up to point the opposite way. Now, if we want to move atoms in a solid, the best way to do that is by exciting a vibration. And vibrations in solids happen on picosecond timescales, which gives us a 0 and a 1 that can switch 1,000,000 times faster than your computer. So let's talk about how that would work. If I take the lithium atom and I map out how much energy it takes for that lithium atom to be at different positions in the crystal, I'll get a shape that looks like a double well, like on my slide. Now, the two lowest energy positions are when the charges add up to point one direction or the other. But in between those two positions, there's an energy barrier, and that's what I care about. But lithium niobate isn't just one lithium atom. There's lithium atoms, niobiums, oxygens, and there's a lot of them. And so if I want to make a complete energy map, it looks a lot more complicated than this. That's where my research comes in. In the lab, I use a high-powered laser, and I excite atoms to vibrate at large amplitudes. And then I watch how those vibrations change over time. And I look at how the energy flows through the sample. With this information, I'm building energy maps for samples like lithium niobate. And once we have these energy maps, we'll be able to look at a sample and use light to manipulate it and make it do exactly what we want. Now, I think research like this is really important. And the future of our technology depends on our ability to use light to make things do stuff, and fast.